Now the third topic which we have is again measuring the volume of objects, but which objects? Which are lighter than water. In the previous section which we have seen is measurement of the volume of the objects which are heavier than water. They will easily settle down in the water. But what happens in the case when the objects don't easily settle down? They keep floating. Let's say thermocol, right? It keeps floating. How will you calculate its volume? Then let's say a piece of rubber, right? If it is irregular in shape, how will you measure its volume? Let us say I have this pen, again its shape is irregular. You see this part, it is irregular. How will you calculate its volume? If you put it in the water, it will keep floating. So for all the objects which keep floating, right, we make use of one more object which is called as a sinker. Sinker we use. So let us see how do we use a sinker to measure the volume of the objects which are lighter than water. So again here also we have two parts. Either we use measuring jar, right, or other way which we can use is Eureka jar. So what are the different steps? Again here all these steps you should remember, they are very much helpful, right? So I will draw a measuring jar here and I will fill water till this level. Now sinker, what do we mean by the word sinker? What exactly do you mean by the word sinker? So sinker, it is a heavy object which easily settles in the water, or you can say that it gets easily sink in the water. Instead of settle, you can also use this word, which easily sink in the water. Like this stone can also be used as a sinker. If you don't have perfect sinkers in laboratories, the sinkers are made up of iron piece, right, or specific metal. But in case if you don't have a specific sinker, you can use this stone. How? Let us say if I tie this pen with the stone and then put into the water, will this pen sink inside? Obviously yes, right? Because of the stone, the pen will sink inside. If I put this pen alone in the water, will this pen sink? No, pen will not sink. So that is about the sinker. So what are the steps involved? So the first step is tie thread to the sinker. I said earlier that you have to gently insert the stone inside. Now this time, since we are using a sinker, right, first we will tie a thread to the sinker and insert it into the jar and notice, or you can say note down the volume, right? You have to note down at what marking does the level appears. These are the markings available. Now, so initially I was having some water. We don't want how much volume of water was there, but now what I do, I put the sinker inside with the help of the thread. As soon as I put sinker inside, there will be some volume of the liquid. So let us say Vi is the volume that is noticed on the jar. So here I will take the observation, right? My observation will be note down the volume. So let us say the volume noted down by me is Vi. Then now step number 2, right? You again take out the sinker, pull out the thread, pull out the sinker, and now tie object with the sinker. So now what I do, I have pulled out this stone outside. Now again with the help of the thread I have tied both of them. After tying, I will again insert them inside. Right, so step number 3, pull out the object with the sinker. Pull out the sinker and now tie object with the sinker. Insert sinker and object in the water. Sinker and the object in the water. What will happen? As soon as you dip inside, right, sinker, and let us say now this pen is also tied, this is my pen, then what will you observe? That the level of the water will go somewhere high till here, right? So now again I will note down the final volume. Let us say the final volume is VF. So insert sinker and object in the water and note down the final volume. So final volume which I have obtained from the reading, let us say it is VF. Now I got the volume of the object. What it is? Simple it is. Therefore, volume of object, it is final volume minus initial volume. Right, now I have got the volume, and mass, you know, by default we use the weighing machine or we use the physical balance. So now easily again I can calculate the density. Now how to carry out the same experiment or same measurement using a Eureka jar? So it is very simple. What to do now? So here again I will draw one Eureka jar, right, and below the Eureka jar I will place a measuring cylinder. Measuring cylinder. This is Eureka jar. So let us say the Eureka jar, again it is filled with this till level. I am not writing down the steps because this method is not commonly used for the lighter objects. So just for the option I am explaining you that you can also do it with the Eureka jar, but I am not noting down the steps. So you have filled the water till this level. So what to do? First you will now insert sinker. So sinker you will put inside. As soon as you put the sinker tied with the thread, there will be some water collected here, right? Let us say the water collected here is Vi. The volume of the water collected is here Vi. Then in the next step, tie object with the sinker and insert into the jar. So now you tie the object, you have tied the pen inside, and then again you are inserting. Then what will happen? Some more water will overflow out, and let us say the final volume observed is VF, right? So again here the same way, final volume minus initial volume. So volume of object is equals to final volume minus initial volume. So this is how you will calculate the volume. So this is calculating the volume of solids, and again these are the solids which are not soluble in the water, like this stone. But let us say if you want to measure the volume of a sugar is soluble in the water. If you use such type of the method, if you put sugar inside, obviously it will sink down, but it will also get dissolved. So for those, again some advanced techniques are used. Those advanced techniques you will study in higher classes, not here, right? So this is about the measurement of the density of the solids. Measurement of the density of the solids. And in the measurement of the density of the solid, what do we need? We need mass and volume. Mass we can easily calculate with the physical balance. Volume, how to calculate the volume? So calculation of the volume, again there are two parts, right? I'll show you the diagram here. Measuring density. How do you measure density? So measuring density, it has two parts. One is for the solids and other one is for the liquids. Gases we don't discuss here. We'll discuss that, discussion will be there in the higher classes. Liquids will study after this lecture. For the solids, again there are two parts. Two parts means solids which are heavier than water, and the other one is solids which are lighter than water. solids we have regular solids, right? Regular solids means whose shapes are well defined, and irregular solids. Regular solids, right? How do we calculate its volume? Regular solids, we calculate its volume using formula, right? Using formula we calculate volume. Measurement of the density, right? The common thing, that mass, how do you measure mass? Mass is measured using physical balance. Simple. And measurement of the volume, these are the parts to measure the volume. So regular solids you can use formula. For irregular solids, what you will use? Either you will use measuring jar, right? I have shown the method, or you will use Eureka jar. Again, in the irregular solids you have two parts. The first part is solids heavier than water, and other part is solids lighter than water. What do we do with the solids heavier than water? We either make use of the measuring cylinder, right? I have already shown you the method, or you make use of the Eureka jar. And at this stage, lighter than water, what we do? We use sinker. Use sinker, and with the sinker we make use of the measuring jar, right? Or we make use of the Eureka jar. So this is the map regarding the measurement of the density. Measurement of the density, mass we directly measure, and for volume again we have this part. So this part we have finished regarding volume, right? We'll start in the next class.